This program is a co-production of Access Alberta and the Southern Alberta Institute of Technology. Although there is widespread use of gang forming systems on commercial projects, there is always a need for loose forming for untypical situations. Loose forming is assembled piece by piece on the job site. Loose forming is specially constructed for tailor-made applications and is dismantled piece by piece. Loose forming is used in all aspects of construction: beams, slabs, shafts, and columns. However, this program deals only with loose forming of walls. There are three major parts to a loose form: the form surface, structural framing members, ties, and hardware. The form surface is usually made of plywood. Its surface texture will be reflected in the surface quality of the concrete. Use of quality plywood will result in durability and acceptable concrete finishes. Structural framing members such as studs and wailers are made of softwood dimensional lumber and strengthen the form surface. The overall strength of the loose form system is provided by a combination of the structural members and the ties wedged together. Ties are readily available in a variety of wall widths. These ties pass through both sheets of the form surface and are anchored on the outside of the structural members. There are many types of forming systems available, but in this demonstration we will concentrate on the basic principles common to all types. If new plywood is used, it is first tacked together and the layout for the whole pattern is established. Simultaneous drilling of all the tie holes saves time and gives a uniform pattern. Foundation footings must be thoroughly swept off before the layout begins. Precise layout with a transit or building line is marked on the footing. Once outside lines have been established, chalk lines are snapped. This chalk line establishes the outside line of the wall. Since the inside of the wall is usually built first, a backset must be established. This backset is equal to the wall width and an allowance for the thickness of the form sheathing. Once the inside line is established, a mud sill or nailer is firmly attached to the footing. Once the mud sills are in place, the form sheathing can be erected. The first sheet must be accurately located and plumbed before fixing to the mud sill. Before the second sheet is positioned, a cleat or scab is nailed to the first sheet to facilitate both joining of the sheets and temporary bracing. Temporary bracing of the form ply prevents wind damage and makes final alignment of the finished wall much easier. Complete erection of all wall forms then follows a similar pattern. Once a number of sheets have been erected, ties can be placed in position. The whalers are then installed. Notice that the whaler is twisted into position so that the snap ties are pulled out. Vertical strongbacks can now be installed behind the whalers to straighten the wall vertically and to provide a stable bracing point. All wedges should be nailed at this time. The straightest lumber should be reserved for the top whalers. This makes final alignment easier. Any required openings, such as doorways, windows, or mechanical box outs, must now be laid out and installed. Doorbox can be partially pre-assembled and must be strong enough to resist the pressure of the concrete. Slight modifications may have to be made to suit the snap tie locations. Remember, doorbucks have to be stripped once the wall is poured. On an actual job site, the second side can be closed up once all inserts and rebar are in place. This procedure is known as buttoning up. Ties have to be jockeyed into position through the holes in the second side. To ease buttoning up, all rough bucks and bulkheads should be cut 5 millimeters under size. The second side can now be whalered. Each end of the wall form must be accurately plumbed and firmly braced. Straightening out the wall between the two ends is achieved with a builder's line. The last step is to establish the pour height within the formwork. If a finished top surface is required, a chamfer strip is inserted. If only a rough finish is required, the pour height is determined by nailing along a chalk line. Having observed the construction of a loose form system, we can now examine some additional details. The hole pattern for the snap ties can be laid out in this manner so that the form sheathing can be applied vertically or horizontally. This pattern maintains constant tie spacing and ease of assembly. The tie holes themselves should be drilled just larger than the end button, but smaller than the spacer. Avoid nailing too close to the corners of plywood sheathing. Since plywood is composed of several layers of veneer, it is easily damaged. A combination of corner nailing and abuse on the job site leads to rapid deterioration. To avoid weak points where whalers are joined, the joints in the top and bottom whalers should be staggered by at least 2 tie spaces. It is also good practice to stagger joints in adjacent rows. This makes alignment of the wall much easier. Running the form wild past the end of the wall will allow for the bracing of the bulkheads. At least one tie should be located past the bulkhead. Wedges should be slanted across the whalers. This increases the bearing surface and minimizes the possibility of the wood being crushed by concrete pressure. Wedges should also be nailed so that they cannot be accidentally knocked off or vibrated loose during concrete placement. Overdriving the wedge should be avoided because this may dislodge the spacer button and affect the wall thickness. There is a very wide range of form ties available. All ties restrict the movement of forms. Some also serve to space the forms a fixed distance apart until the concrete is placed. The earliest kind of tie was simply made by looping heavy wire through the formwork and twisting it in the center. This wire tie served its purpose, but did have several drawbacks. It was time-consuming to install. It did not space the forms on its own. It was weak. It left the wire at the surface of the concrete where it rusted. Modern ties have been developed to avoid these problems. The main function of the tie is to maintain a constant wall thickness. This is set by the distance between the spacer washers. Each tie has a special breakback or weak point so that the tie can be easily removed once the concrete has set. The breakback is set well inside the finished concrete surface to allow for patching. To prevent the tie from turning within the wall, A special deformation is provided that keeps the tie secure. The distance between the end button and the spacer button must accommodate the form plywood, the whaler, and an allowance for the wedge. If the job requires a stronger tie system, then a longer tie end is required as well. This allows for the plywood, vertical studding, the horizontal whaler, and an allowance for the wedge. Steel washers are sometimes replaced by a tapered plastic cone. This produces a better cavity for patching. Alternatively, the cone cavities are left unpatched as an architectural feature. An added feature on some ties is a water stop. This prevents water seepage in specialized applications. This particular tie has a hexagonal end button which allows for twist breaking before or after the removal of the form. The cone feature of this tie makes tie breaking easier than the standard type. Loose forming will always be needed for untypical job site requirements, even where there is extensive gang forming for large areas of wall.